I've now got to a point where I am satisfied with my slab design. It has been well optimized, and I'm ready to move into the final stages of reviewing and completing my design effort. So, first, I'll click Save. We never want to lose the work that we've done, and then move into Calculate Final Result. Now, this will bring us into a results view. So the overall result is in the top left corner at 94%. So this is the worst case utilization of any of the different loads and different failure modes that are being checked within the software. To the right of this are the different load types and a summary of the different failure modes that are being reviewed. So the point loads is showing that that is a 94% utilization, which I can see to the right is being driven by this first column, which is indicated as BE. BE stands for bending. So this is the flexural response of the slab. So that's what's controlling. The other failure modes that are being studied are SH for one-way shear, PU for punching shear, and SO for soil. If you remember, we defined a soil stiffness, that subgrade modulus earlier. There's a certain allowable settlement or deformation that is tolerable within the program. And so this is checking that. We can also see what is controlling the design, and also the magnitude, so to speak, of the color will also show you where that is. So the more light colored green will show you where the demand is lower. The kind of middle level coloring shows you where it's in the moderate range, and then the darker green shows you where it's more optimized, so to speak. We can also now scroll down to drill down a little bit deeper into the loads. In this particular example, the different load types are shown here, similar to how we have all the different settings for the project settings, the loads, the materials, and structure. We have point loads, wheel loads, UDL, and line load. If I go back to point loads, we also have all of the different potential locations where these can be defined. So if you recall, the slab center is the default, and then relation to the free edge, saw cut joint, parallel to the doweled profile or construction joint, perpendicular to the free edge, and so on and so forth. So now we can see what is really driving the design of this particular project. At 94% is the bending response with those rack point loads parallel to the free edge. So at this phase in your design, if you have faithfully entered everything as you understand it, you may be done. But it's possible that you entered some information as a kind of guess. And now this might be a reason to say, do I want to revise or refine or do some extra study on this particular loading scenario? Is it realistic that that loading really will be that close to in the parallel to the free edge condition? In which case, perhaps I want to go back, right, and go into my input screen here and make some changes. Or if you feel as though the loading that you've entered is accurate and appropriate, then you would just leave it as is. Next, we can look into the wheel loads. Similarly, we see that those wheel loads that we had, the one axle, two wheels, is actually really low utilization. Our uniform distributed load doesn't check all of the different failure modes because one-way shear and punching shear really does not apply for a large uniformly distributed load. And then finally, our line loads that we define, we have fewer locations of the project where this is being checked, and we had deselected the free edge. If we're satisfied with all of these results, then we can move into the final stage of printing our calculation. So when we go to print, first you'll have the PDF language to select. English EN, you may be tempted to select that as an English speaker in the US. However, that will be in metric units. So use English US to ensure that you get English US units on your printout. Additional comments to be shown. If you have some additional notes that you would want to include, you can do that in your project right here. And then we have 3 different printout options. Summary printout, which is the shortest option with the lowest amount of detail. It has the essentials and basically a high-level calculation overview. The extended printout option, this is going to be everything that's in the summary with a bit more. So now it's going to have a little bit more detailed information, some additional formulas and explanations. However, myself personally, as a former structural engineer, and when I work with the structural engineering design partners that we have relationships with, I always like to send the complete printout. This is going to be the most detailed output, showing all of the key design information as well as equations and so on that go into the calculations that this software is doing. So if this is the option that you select, you would click print. Now, a word of note, you're getting a message here. Your report is being generated and will be ready in a few minutes. Please check the homepage or your inbox shortly. So you will receive an email directly from this tool with your printout. You will also have access to it through your home screen here. There's a note, please be patient. Preparing the printout may take a while. I do want to caution you to please take this seriously. It can take several minutes. So I encourage you to please be patient, go grab a coffee, and by the time you return, hopefully your printout will be ready and waiting for you.